In this video, I'll show you how to use implicit differentiation. This is part 3 in the series. Question 1 asks us to find dy over dx given the following equation. X squared plus 3x to the power of 3y plus y squared is equal to 4xy. They want us to find the derivative with respect to x. Let's start by deriving the first term. X to the power of 2, we use the power rule here, that is 2x. Now since it's with respect to x, we won't write down dy over dx next to it. Plus, now we have this term, 3x cubed y. To derive this, we'll need to use the product rule. So I'll do my work over here, and then once I'm done, I'll put it over here. 3x to the power of 3y. The 3 in the x cubed is my first function, and y is my second function. I'll find the derivative of 3x cubed, multiply it to y, and then add the derivative of y to 3x cubed. The derivative of 3x cubed is 9x squared y, plus, I'll leave this the way it is, and find the derivative of y, which is 1. 1 dy over dx. So I'll take this whole expression and place it right here. Next, I'll find the derivative of y to the power of 2, and for that I can use the power rule. Y to the power of 2 becomes 2y dy over dx. And I'll place that right there, plus 2y dy over dx. And finally, I'll find the derivative of 4xy. Once again, I need to use the product rule for this. 4xy, I'll find the derivative of these two, multiply to y, and then add the derivative of y to 4x. The derivative of 4x is simply 4. Y stays the way it is. Now I leave 4x the way it is and find the derivative of y, which is 1 dy over dx. So I'll place this expression right next to this one. Is equal to, now that I've made all the room that I need, I will group all the terms that contain dy over dx next to them. So this term right here, this term, and this term will be grouped together on one side. For that, I'll bring this over and I'll bring this term over. And at the same time, I'll bring 4y over to the left side, giving us 2x plus 9x squared y minus 4y, bringing this over makes it negative, is equal to 4x dy over dx. This part stays where it is. This part moves over. It becomes negative 3x cubed dy over dx. And this becomes negative 2y dy over dx. The reason why I did this is because now I can factor out dy over dx on the right side. And if I do that, I should end up with dy over dx bracket 4x minus 3x cubed minus 2y. And on the left side, this part stays the way it is. All I have to do now is divide both sides by this expression, and I've isolated for dy over dx, and I've successfully found the derivative. So my final answer is dy over dx. This equation represents the derivative. Let's move on to question 2. In question 2, they want us to find out the differential dy for the following equation. Y is equal to 3x squared minus 2x plus 5. Now before I begin this, up until now, we have treated the symbol dy over dx as a whole. Take for example in question 1. And not as a quotient of two quantities, dy and dx. In this example, we will give dy and dx separate names and meanings of their own. The quantity dy is called the differential of y, and dx is called the differential of x. In fact, the differential of y is defined as the derivative of f at x dx. And that makes sense because dy over dx has always been represented as f prime of x. So if we multiply both sides by dx, we will end up with this expression. And if you ever do it this way, the expression is said to be in differential form. So in our example here, they want us to find the derivative with respect to x, as we did in question 1, but then solve for dy. That's not hard to do. I'll make some room up here. So I'll start by finding the derivative of y. that is dy over dx, is equal to the derivative of 3x squared is 6x. No need for dy over dx over here because it's with respect to x. Minus 2 plus 0. 5 goes to 0 when you're taking the derivative of a constant. Now all we have to do is multiply both sides by dx. And our final answer is dy is equal to 6x minus 2 dx. An equation containing a derivative, such as this one, is called a differential equation. And there you have it. That is how to use implicit differentiation.